Bottomless Metal Arch culvert installation.
The existing culvert was what we call a hanging culvert. It was perched up above the channel bottom. The outlet basically was too high, so the water dumped down into the brook, and it was too high, didn't allow fish passage. We thought this would be a good opportunity since the arch seemed to fit really well, and it was economical solution as well.
Construction drawings, review plans. Before construction starts, a design needs to be completed that shows enough detail so the culvert can be installed properly. For a culvert, the key components are the location of the culvert, the bottom elevations of the footings, and the design channel elevation through the culvert, along with the specific details of the culvert, such as dimensions and other structural requirements. The plan view from the construction drawings show the location of the culvert and elevations of the channel. All elevations are established from a benchmark that is typically set during the initial design survey, and a description is provided on the plan view of the construction drawings. Other sheets of the design, specifications, and construction notes include specific details for the assembly of the culvert and associated components, and should also include the specific requirements for water, erosion, and sediment control. The construction drawings should be provided to and reviewed with the contractor prior to construction.
We basically selected this type of open bottom arch because the size of round pipe that would be required for flood conveyance would have been very large, close to probably a 60-inch pipe, and couldn't really get that to fit in the channel without lowering the channel or raising the road, and that's something we really wanted to do. So the open bottom arch allowed us to provide the hydraulic capacity that we needed, as well as providing the aquatic fish habitat benefits as well.
Water control. Water control typically consists of diverting all existing stream flow around or through the working area of the construction site, keeping any of the stream flow clean as it passes through the crossing area. For this site, the existing pipe was used to bypass clean water through the construction site instead of pumping the water around the site during construction. This is the downstream end of the old culvert before any work started. Using an existing basin at the outlet of the culvert, the contractor installed a geotextile sediment barrier to help catch sediment. At the upstream end of the pipe, steel plates and sandbags were placed to direct all stream flow through the pipe and keep the disturbed work area out of the flow going through the pipe. On the downstream end of the pipe, steel plates were also installed to keep the stream flow out of the footing working area and minimize sediments from the working area entering the stream and sediment basin. As the settling basin filled, flows that trickled out over the top of the sediment basin were relatively clean when re-entering the stream. Any dirty water encountered in the disturbed work area was pumped into the woods a far enough distance from the stream so sediments were removed prior to water re-entering the stream. On-site preparation prior to construction, delivery of materials. Prior to construction, materials and equipment needed should be brought to the site in order to minimize actual construction time. This is important in order to minimize the time the road has to be closed, and can be critical if there are higher stream flows and water control is more challenging. Materials needed to construct the concrete footings and place the culvert should already be on site when they are needed. Required earth and gravel fill needed for the backfill of the culvert and road construction associated with the culvert should be stockpiled on site as much as possible. There are typically on-site storage limitations for the entire earth and gravel fill needed for the construction site. However, stockpiling at least some of the earth and gravel fill can save time during the installation, especially if the earth and gravel source is a long distance from the site. Construction start, initial excavation. If carefully done, a large portion of the excavation can be done before the water control is initiated, as long as sediments can be kept out of the stream. For this site, it was most effective to install the downstream sediment basin and upstream steel plates and sandbags prior to any excavation. A portion of the road fill was removed down to the level where concrete footings needed to be constructed. The pipe was left in place during the construction of the concrete footings. Leaving the pipe in place allowed the flow to go through the working area and kept the flow away from where the footing construction was taking place. Utilizing the existing pipe for the stream to bypass through the site also eliminated the need to pump any stream flow around the working area. Constructing the footings and establishing the stream channel. The footings for this were poured in-place concrete. The footings were placed on a firm, well-drained base material. The amount of well-drained base material that has to be brought in depends on the existing material below the footings. If the existing material is not suitable, it may have to be excavated and replaced with a well-drained base material. The base of the footing is designed to be lower than the design channel bottom to prevent the undermining of the culvert footings. Here they are constructing the pour-in-place concrete footings. Once the footings are in place, the existing pipe is removed and the channel is excavated and shaped to the design shape and elevation. During the final shaping of the stream channel, any needed riprap armoring of the inside of the footings should be done prior to placing the arch culvert on the footings. The amount of riprap reinforcement against the footings should be limited to only the amount needed for stabilization in order to minimize encroaching on the stream channel bottom. Installing the arch pipe. The arch pipe was a 4-foot, 2-inch high by 8-foot wide single-span arch. The full span of the arch was formed by bolting together smaller plate sections. Several plates were bolted together out of the stream site prior to placement to minimize the amount of time spent in the streams assembling the pipe. This allowed the pipe to be placed on the footings with just 4 pre-assembled sections. The backfill next to the arch culvert is placed in 6 to 12-inch lifts that are mechanically compacted with a hand compactor, typically in an envelope area specified by the pipe supplier or as shown on the construction drawings. The raised concrete footings or knee walls for the arch extend 6 inches above the stream bottom to keep the metal out of the water during base flows, thus helping minimize long-term abrasion and corrosion. Stone blocks from the old head walls, as well as new riprap, are used to stabilize the road embankment for the new arch culvert. Completed arch culvert backfill and adjacent road backfill. The backfill for the road beyond the designed arch culvert envelope backfill is typically just compacted with larger equipment such as an excavator or bulldozer. Even though the road fill beyond the culvert envelope backfill is typically not mechanically hand compacted, it still should be placed in lifts no greater than 12 inches with adequate compaction between lift placements. This will help to minimize settling in the road surface, especially closer to the culvert. The entire surface of the slope on both the upstream and downstream ends of the culvert is armored with either the old stone blocks from the previous pipe or new riprap. This reduces erosion potential of any of the compacted gravel fill during high flow events. If the opening for the culvert is properly sized, sediments will typically be deposited upstream, downstream, and under the culvert to form a continuous natural low-flow channel. For sites where normal stream sediment transport will not deposit the desired stream bed material under the culvert, the channel shaping procedure may also require replacing the proper bed material in the stream prior to placing the arch culvert on the footings.
Initially, we weren't planning on doing this type of structure. We were just planning on putting in a new, bigger pipe, but once we started looking at all the different options, this ended up being the most cost-effective and giving us the best product at the end. So I think it's important to look at all the different options out there when designing these.
With a properly sized opening, the natural channel continues uninterrupted under the culvert and can adjust according to storm intensities and sediment transport loads. The stream can act naturally and the road is invisible to the stream. Support for the production of this video comes from Poland Spring, the Sewell Foundation, and the USDA Natural Resources Conservation Service. StreamSmart is a collaboration of the following partners. Thank you to the following organizations and individuals who helped make this video possible.